Okay, let's look at another example. When we are riding a bicycle, then when we pedal, then we move the rear wheel, and the rear, suppose we have to move forward, we are riding it in this direction, then the rear wheel will be moving clockwise. Now at this point, if you see this, the lower end of the wheel has a tendency of going towards left, so friction acts towards right. Friction opposes relative motion. Now there's a mechanical contact between the rear wheel and the front wheel, and our pedaling has no effect on the front wheel as such directly, but due to the mechanical contact, since the lower wheel tends to move forward, then the forward wheel also will be moving forward, and then this point has a tendency of going towards right, so the friction acts towards left. This is how the friction acts when we keep on pedaling, and this friction is higher in value than this friction, so there's a net force in forward direction. You see, friction value depends upon normal reaction. Since you are sitting on the side nearer to the rear wheel, so the normal reaction at this point is higher than normal reaction at this point. So this friction is higher than this friction. There's a net force in forward direction, and that's why the whole bicycle moves in forward direction. When you stop pedaling, then what happens? Friction always tries to stop relative motion. Then with respect to ground, the whole bicycle is having a relative motion towards right. Now in order to stop that, if friction acts in backward direction, it will try to pull back the entire bicycle. So in that way, it can stop the relative motion. So friction, after you stop pedaling, acts on both the wheels in backward direction in order to stop the relative motion. So this force is going to decrease the velocity that the bicycle has gained, and gradually the bicycle is going to stop. So this is how the friction initially actually helps us to ride the bicycle. Had there been no friction, then this wheel would have been rotated on the same point of at ground. It would have keep rotating and the bicycle wouldn't have gone forward. Okay, so friction helps in motion. Friction doesn't always opposes motion. Friction a lot of time supports motion. Similarly, if a truck, suppose, is carrying some good and it is not chained, the good is just kept it like this, as is the case in most of the time. If the good is just kept like this, and had there been no friction between the good and the truck, then the truck would have been passed by and the good would have remained there, because the forces acting on the good would be mg and normal reaction, and the only horizontal force that would be acting on this good would be friction force. And friction force, now you have to start working on the direction of friction force. What will be the direction of friction force acting on this good? Friction force tries to oppose relative motion. If there would have been no friction, suppose, then the truck would have moved forward and the good would have remained here as it is, because there is no other horizontal force acting on the good. Now the truck would move to its right relative to the good, and the good would be moving to its left relative to the truck. So the friction will try and oppose this relative motion. How can it oppose the relative motion? It can oppose the relative motion by supporting the motion of the good in the direction of the truck, so that the good moves together with the truck and there is no relative motion. That's the job. That's how you will that's how you will find out the direction of friction. Friction should act in such a direction that it is opposing relative motion. In this case, the friction would act in forward direction, so that the good moves along with the truck and it tries to minimize and oppose relative motion. So this is the direction of friction. Had there been no friction, then it would have been difficult to carry things like that just on its own without chaining it. So this is another example where friction is supporting motion. Okay, there are many advantages of friction. For example, when we use matchstick, the friction, due to friction there is some rubbing. Due to that rubbing, there is some heat loss. There is some mass loss, and that mass turns into energy, heat energy. and that ignites the matchstick. If there would have been no friction, then there wouldn't have been any losses as such, and this ignition of the matchstick would have not been possible. So because of rubbing, because of friction, these kind of things are possible. Similarly, when we apply brakes, you must have experienced in your bicycle, when you ride the bicycle, when you apply the brake, there's a mass which touches the rim. When you apply the brake, that piece of mass, piece of rubber that touched the rim, and it starts rubbing the rim, and that rubbing actually there's some friction acting between the rubber and the rim, and there's some loss of energy that goes into heat, and that loss of energy comes from the kinetic energy of the wheel, and the wheel gradually stops. If you apply the brake very hard, it stops immediately because the friction value is very high. When you press your brake very hard, then what happens? This rubber presses with the rim very hard, and friction force depends upon the normal reaction. The contact force between the rubber and the rim would be very high because you're pressing it very hard, and friction force is proportional to the contact force. So friction force there becomes very large friction force, then there is very high rate of energy loss, and in no time the rim stops. So had there been no friction, then you could have not stopped your bicycle just by applying brakes, and and any other vehicle for that matter, you could have not stopped just by applying brakes. So this is the advantage of the friction. Even though you are having the mass loss over the period of time, the rim is going to suffer, the rubber is going to be thin, and you have to replace that. But that is the only way you can work this thing out. Friction, although is resulting in mass loss, but it is acting to our advantage. Similarly, when you are writing on a piece of paper with a pencil, then you are able to write because the graphite from your pencil lead that comes to the paper, it leaves an impression, and in whatever direction you move your pencil, you are able to write on that. Because remember the peaks that we discussed about, they break when the friction is acting, and they break, certain masses is left on the paper, and that's how we are able to write it. And over the period of time, you have to change your pencil because it becomes short and short because of mass loss, and you have to replace it. But that's the only way you can work things out. Friction is having some mass loss, but we are using friction actually to our advantage, and we are able to write on a piece of paper by pencil. Similarly for pen, you hold your pen like this. That means the force that you are applying is oblique to the piece of paper. There will be some normal reaction. Suppose you are holding your pen like this. Now this is the direction in which you are applying force. There will be two components of force, perpendicular to the plane of the paper and horizontal. This is going to be countered by the normal reaction by the surface, but this is countered by friction. And that's why you're able to hold pen like this. Otherwise, holding pen like this would have not been possible, because this part would have been countered by normal reaction, but this would have gone uncountered because if there is no friction, then this force will remain unbalanced. So the pen will start to move, it will slip. You cannot hold anything like this. You cannot hold anything like this. I'm holding the marker like this only because there's friction force acting in backward direction. Otherwise, the marker would slip. You cannot hold anything in this direction had there been no friction. It would simply slip. Okay, so this component of force is countered by friction, and you're able to hold anything like this. Otherwise, it wouldn't have been possible for us to hold pen in a slanted position. It would slip. Very difficult to write unless you keep the pen normal.